For this problem, we're asking whether the equations of the pairs of lines are parallel, perpendicular, or neither parallel nor perpendicular. So the question is, these two, there's a pair of equations, those represents lines. What's the relation of those lines? Are they parallel, perpendicular, or neither? What we look at is the slope. Could sketch the graph, but really we need to look at the slope. So for the first problem here, we have, well, I need to find the slope. And the one way is to put this in y equals mx plus b form. So what I'm going to do is I'm going to write in y equals mx plus b form, and m is the slope, and so that should answer a lot of questions. So I'm going to write 3y equals negative x plus 12 by subtracting x from both sides. And this will give us that y equals, divided by 3, negative 1/3 x plus 2/3. Okay, so this is 3y plus x equals 12. So I'll start with that one. And now I look at the other line, and that's negative y equals 8x plus 1. If I multiply by negative 1, well, sort of funny that this is the first problem, but anyway, this line says m1 has slope negative 1/3, and the second line, m2, is equal to negative 8. They're not the same, so I can say m1 does not equal m2, so it's not parallel. So two lines are parallel if and only if they have the same slope. Two lines in the plane are parallel if and only if they have the same same slope. By the way, parallel has two L's in the middle. It's 3 in total, but 2 in the middle, and it's like those parallel lines. Only one R. Okay, M1 is not perpendicular. Actually, that's not really the right thing to say. We're going to find m1 times m2, and if m1 times m2 is equal to negative 1, they're perpendicular. It's not equal to negative 1, so it's not perpendicular. So what we're looking for is that the two lines have negative reciprocal of each other. In other words, m1 times m2 is equal to negative 1, but that's not the case. So they're not perpendicular either. Sort of a lot going on in this problem, actually. Okay, let's try this other one. Maybe we'll get better luck out of this. Something more interesting will happen. So, so we have three problems I'm going to go over and look at all the different things that happened for those three. So the first one was sort of a dud. Didn't get anything out of that. 6x minus 9y equals 10. I'll subtract 6x from both sides, and then negative 9y equals negative 6/10 plus 10, or negative 6x plus 10. Divide by negative 9. So y equals 2/3 x minus 10 over 9. And this is going to equal, say that m1 equals 2/3. I'm deciding this one's, the first one's m1. I could, correspond that to L1, L2 are the lines. And then I go over to the next L2. So this is for L1. For L2, I have, write it like this. Okay, L2, I'll have 3x plus 2y equals 1. If I subtract 3x from both sides, I get negative 3/2 x plus I'm doing too much at once. If I subtract 3x from both sides, I get 2y equals negative 3x plus 1. Divide by 2. So m2 is equal to negative 3 halves. The relationship between these two is that they are negative reciprocals of each other, which means they're perpendicular. So what I have, though, is I see that I want to write it a little more precisely. m1 times m2 is equal to 2/3 times negative 3 halves, which equals negative 1. And therefore, the two are perpendicular. The way we can write perpendicular is by this upside down L symbol thing here. It's pretty commonly used to say that the two lines are perpendicular. They use an upside down, not an upside down L, upside down T. That's what I meant to say. Okay, now we'll move on to the next one here. Here, the first one we already have is sort of good to go. L1, that's y equals 3/4 x plus 1. For L2, so m1 is equal to 3/4. For L2, we have negative 3x plus 4y equals 1, which can be written as 4y equals 3x plus 1 by adding 3x to both sides. And if I divide by 4, I get 3/4, y equals 3/4 x plus 1/4. So what I take away from that is that m2 is 3/4. So then I'm going to write down that m1 equals m2, which implies that L1 is parallel to L2. All right, parallel. All right, if you have the slopes equal to each other, we have parallel lines. If the product of the slope is -1, in other words, the relation is that they're negative reciprocals of each other, then the lines are perpendicular. On the first one that we went over, the slopes were not equal, and the product of the slopes was not -1. So therefore, it was not perpendicular and not parallel. It was neither. It was a nothing for that guy. Okay, so that's 2.2, Openstax 7, 9, and 11, 3 consecutive odd problems.